Hi guys, it's Claire again. Welcome back to my channel. Make sure you subscribe to my channel and hit that notification bell. Today I'm going to be dealing with measurement 2. It's a continuation and dwelling on the micrometer screw gauge. The micrometer screw gauge, just to give you a hint, is used to measure small distances such as the diameters of thin wires, small lengths. Yes, welcome. Diagram of a micrometer screw gauge so that you can be able to know what is this that you're talking about. Let's start on the parts. We have the anvil. The anvil is the part that the object to be measured rests upon. Then below it we have the frame. The frame is the C-shaped body that holds the anvil because it's below the anvil. The sleeve it's beside the lock nut. So the sleeve is the round part with the linear scale, which is graduated in millimeters, so it's like the main scale. We have the lock nut where you can be able to adjust. Then we have the baseline. We have the main scale just there in the baseline below it. Then we have the thimble, the part with the revolving scale, which is divided into 50 equal divisions, and others is 100 equal divisions. Then we have the ratchet, the part at the end of the thimble that limits the applied pressure on the object being measured, and necessary pressure. Then we have the micrometer scale, which is on the thimble. Yes, that's all about the parts. Let's tell more about it. Micrometer screw gauge. The micrometer screw gauge, as we had said earlier, is that it's used to measure small lengths or the small diameters, such as the diameter of thin wires. Like these small lengths, like the thin wires with thin wires, the micrometer screw gauge is capable of measuring. A micrometer screw gauge consists of a U-frame or the C-shaped body that you had said, carrying an anvil head at one end, not head, a thimble, which is rotating scale known as the thimble scale. It can be able to rotate, so it has that capability of rotating, and a spindle, which can move forward and backwards when the thimble is rotated. So that spindle, which is cylindrical in shape, can move forward and backward when the thimble is rotated. Micrometer screw gauge is that the sleeve, the one that had the main scale or the sleeve scale, has linear scale in millimeters, and the thimble has a circular scale of 50 equal division because some that can be rotated, so it's more likely to be circular. And others had 100 equal divisions, but it's very rare to find them. The ratchet at the end of the thimble, as we had said, is that it prevents the user from exerting undue pressure. When you say undue pressure, it's pressure that is not needed on an object when the micrometer screw gauge is in use. In other terms, or in simpler terms, is that it limits the applied pressure on the object being measured. The distance moved by the spindle in one complete rotation of the thimble is known as the pitch of the micrometer. It depends with the divisions that the thimble has. If the thimble has 50 equal divisions, then the pitch is 0.5 millimeters. But when the thimble has 100 equal divisions, then the pitch is 1.0 millimeters. Just a scale which is more of zoomed so that you can see it more better. So in the figure, since the spindle advances or retreats by 0.5 millimeters per complete rotation of the thimble, the pitch of the micrometer is 0.5 millimeters. In our example here, or in the diagram we have here, we can see that the thimble scale has the 50 equal divisions, meaning that the pitch is 0.5 millimeters. When the spindle, we say that when the thimble is rotated, it makes the spindle to move forward and backward, and when it's moving this, it advances or it retreats by 0.5 millimeters per complete rotation of the thimble. This is an example of a micrometer screw gauge with 50 equal divisions. More about it, thus each division represents a speed of travel of 0.01 millimeters. So you take 0.5 millimeters divided by the equal divisions, which is 50 millimeters, then we get the speed of travel per each division is 0.01 millimeters. So micrometer screw gauge has pitch of 1.0 millimeters, and the divisions in this, we had said that it is 100 equal divisions on the thimble. Now let's start on reading a micrometer screw gauge, or how do you use it. Yes, first of all, the object to whose diameter is to be measured or to be determined is fitted between the spindle and the anvil and then held gently by turning the ratchet. We say that the ratchet, to remind you, is that it prevents the user from applying undue pressure when measuring the object. Okay, let's start on the sleeve and the thimble readings, or the sleeve and thimble scale readings are taken then added. Let's start on the first example here. For our first example A, the reading is for the first one is 6 on the sleeve scale, then on the thimble 25, 26, 27 millimeters. So it's 5 plus 0.27 millimeters. So it's 5.27 millimeters. On the second one, it's 15, 16, 17. 17 on the sleeve scale and 42 on the thimble scale, which is 0.42. So you add 17 plus 0.42. So you get is 17.42 millimeters. The other one, we don't have the scale on the thimble, so I'm not going to give the answers. But that is how a micrometer screw gauge is read. In the first example, now you can see detailed. Now reading screw gauge. Okay, the sleeve scale on the first diagram is 6 millimeters. Then the thimble scale is 0.68 millimeters. So we add together 6.68 millimeters. Because here on the thimble, you can see it's 65, 66, 67. We read where the start complete joining of the sleeve scale and thimble, that is 68. The second diagram, we have the sleeve scale, which is 7, and the thimble, which is 47, which is 0.47. We get 7.47 millimeters. The other one is the sleeve is 9.5, if you can see keenly. Then the thimble is 0.24. Now we add, we get 9.74 millimeters. These are just so many examples. It's very easy to read. Yes, you just have to be keen when we have the 0.5s. Yes, the zero errors. In the other video, we also had the zero error of the vernier calipers. Now here we also have a zero error of the micrometer screw gauge. It arises when the zero error of the thimble scale does not the zero mark of the thimble scale does not coincide exactly with the center line of the sleeve scale when the micrometer is closed. And when we say it's closed, means there's no object that is being measured. The anvil is used for the adjustment of the zero so that the micrometer has no zero error. So the anvil is very helpful. It just helps you adjust, then the zero error is gone. Let's see the zero errors, the type of zero errors, because that shown on the screen is a positive zero error. Okay, and the positive is positive by positive 0.02. When we have this is when the zero mark of the thimble scale does not coincide with the center line of the sleeve scale, but it's below it. When it's below, it's positive. And when you get this, you minus the observed reading minus the zero error. For example, in our diagram, we have 2.37, which was the reading that they got, minus the positive 0.02 millimeter zero error. Then we get 2.35 millimeters. So the positive error is below the zero error, the zero mark of the sleeve scale. The negative zero error. The negative zero error is added, and its zero mark of the thimble does not coincide with the center line of the sleeve scale. Okay, like in our diagram, the reading was the reading is 5.99. Then the negative zero error, which is added, was 0.06. Now we add, it becomes 6.05 millimeters. All about the micrometer screw gauge. Hope you enjoyed. Thank you for watching my videos. Make sure you subscribe, like and share, and also comment on my videos. Bye.